so today in class you learned how to factor a quadratic function with the a value being 1. So in each of these 10 you have to factor and find the two binomials that multiply to give you that trinomial. So you're always looking, remember it's ax squared plus bx plus c, you're always looking for two factors that multiply to give you c and add up to the b term. So in this case, we're looking for two numbers that multiply to give us 12 and add up to -7. Okay, so those two factors are obviously going to be 3 and 4, but 3 plus 4 is not -7. -3 plus -4 is -7, and -3 times -4 is 12. So the answer is going to be x minus 3 times x minus 4. And those would be your two binomials. On the next one, you're looking for two numbers that multiply to give you -15 and add up to -2. So we're going to use a 3 times 5, and one of them is going to have to be negative in order for it to be a -15. And since we need a -2, we would do -5 plus 3, which is -2. So my two factors are x minus 5, because -5 was one of the numbers, and x plus 3. In the next one, we're looking for two factors that multiply to give us 30 and add up to 11. So that's going to be 6 and 5. 6 plus 5 is 11. 6 times 5 is 30. So your answer is x plus 6 times x plus 5. This one, we're looking for two factors that give us -10 and add up to +3. That's going to be 5 and 2. One of them has to be negative, and since we want a +3, the 2 is going to be negative. So we're going to have x plus 5 times x minus 2. All right, and the next ones, we got the 5 and 6 are difference of two squares. So notice that this is x squared and this is 15 squared, and it's a difference right there. So since x is the first term that we square and 15 is the second term that we square, our answer is just the first term plus the second term and the first term minus the second term. So x plus 15 and x minus 15 would be our final answer. Here we squared x and we squared 12, and it's difference. So it's going to be x plus 12 times x minus 12 as our final two binomials. All right, and in 7 through 10, we have only two terms. It's not a difference of two perfect squares like number 5 and 6, and it's not a trinomial like numbers 1 through 4. So in this one, you have to factor out the greatest common factor. So you're looking between the two of them to see what they have in common, which is an x. That goes on the outside, and then you're basically doing the distributive property backwards. So x times what would give you x squared? That would be x. And then x times what would give you 7x? And that would be 7. If when you distribute you get what you started with, then your answer is correct. So this would be x times x plus 7. In number 8, they not only have an x in common, but they also have a 3 in common, because 3 and 6, the GCF is 3. And between x squared and x, the GCF is x. So 3x goes on the outside. On the inside, we're going to do 3x times what gives us 3x squared? That would be x. And then 3x times 2 would give us -6x. So that would be our final answer there. In number 9, between 2 and 14, 2 is the GCF. Between x squared and x, x is the GCF. So 2x is my GCF. 2x times what gives me 2x squared? That would be x. Plus 2x times what gives me 14x? That would be 7. So we have 2x times x plus 7. And in the last one, between 5 and 20, 5 is the GCF. and 20 does not have an x, so they don't have any x's in common. So when I factor out a 5 times what gives me x squared? That would be x squared. And then 5 times what gives me 20? That would be 4. Now what you notice here is this is a difference of two squares. This is x squared, and this is 2 squared. So we not only have the 5, but we also have this can become x plus 2, like we did in numbers 5 and 6, times x minus 2. So if it can still be factored, you have to continue to factor it. So this would not be simplified. So we need to simplify that more and do the dots to get this. So our final answer would be 5 times x plus 2 times x minus 2.